I have noticed that you are uploading your assignment in the landscape mode. You have to upload it in the portrait mode. Okay, na? Because in that manner, I have inconvenience in checking the
Sir,
paper. Yeah.
portrait it like this or
No,
like this?
portrait is like this. Landscape is like this. That is landscape. That is portrait. Okay.
This.
Hmm. The one that I would on. Yeah, like this, as you were saying, like this.
Okay.
Mhm. So write the following points about this. So finding a step by division method, you're going to simply write the steps. Step number one would be to divide the large number, divide the large number by the small number, small number, or you can say smallest number. Okay. Then step number two would be to take divisor in the first initially you will take the divisor as the new dividend, right? So step number two is that take divisor as new dividend and remainder as the, yes Abhi, what about the remainder? That will be taken as the new, yes, your answer?
Divisor.
No, the remainder,
No, no, no.
yeah, you're saying correct by the way, as the new divisor.
Yes.
Good. And remainder as new divisor. Okay na? Okay. Furthermore, in step number three, write down proceed till the remainder is zero. Proceed till the remainder is zero, and the last divisor will be the HCF, will be the highest common factor. Write this much. And before moving on to the next topic in the chapter, we would like that is divisibility rules. Let us practice one question so that you don't forget this concept. Okay, Habib? Okay. So we'll be practicing one question before ending this topic. So the question is, Habib, do you speak Urdu or not?
Yes, I speak Urdu.
Good. So for the numbers 72 and 140, we will be finding out the HCF using the division method. And you take Arabic classes also, right?
Yes.
Okay. There, what do you learn? Like the grammar or just the translation?
Uh, Arabic classes. No, I don't take, I guess.
Okay, you don't take Arabic classes. Okay, okay.
Wait,
Yeah,
I'll ask.
no need to ask that. Not necessary. Write down the definition.
No, I don't.
Mhm. Habib, meanwhile you are writing down this, answer some of the questions also. Is one a factor of every number, or is one a multiple of every number?
Yes, one is a factor of every number.
What about the other statement?
And
Is
the
one,
question, what did you?
yeah, the question was, is one a multiple of every number, or is it a factor of every number? One, is it a
It's a
multiple?
multiple. It's a multiple.
How can one be a multiple of every number? One is the multiple of only one, no? Like, apart from one, when you read the table of two, three, or any other number, apart from one, will this number one be coming in its table? Hmm?
No,
Like, no, no. And we know about multiples, what a multiple is. We have learned about multiple. When you have any given number, you multiply with another number, you get its multiple. So one is not the multiple of all the numbers, but it is a factor of all the
factor.
numbers. Good. Okay, do let me know once you're done and try to write it quickly.
Sir, can you read the second step?
Take divisor as new dividend and remainder as new divisor. Take divisor as new dividend and remainder as new divisor. By the way, have you received the syllabus of your final exam? I suppose right now it would be
Yes,
too early.
yes,
You have?
yes.
Okay, that's good to know. Okay, do one thing. Share it after the class or in the class if possible. If you can share it in the class right now, it would be very better. Very good. Okay,
Okay,
na?
I will ask.
Yeah.
So I have PT1 syllabus. I don't have the exams. PT1 syllabus. Yes, yes, syllabus.
But PT1, you wouldn't have given that exam, no? You'd be only giving the final exam, no? So far in your school, you haven't given any exams now. That's what I know. That you haven't given any exam. You will only be giving your final exam, right?
Yes, I'm only giving final exams.
Yeah, okay, okay. Whenever you get your final syllabus for your final exam, make sure that you share that. Okay.
Okay.
Mhm. Okay, write it fast. Yes, so we complete writing this fast.
Sir, done.
Done? Good. Okay, here we have a question. We have the number 72 and 140. We have to find its HCF using the division method. So first of all, you try to solve it quickly.
By division method, right?
Yeah, by the division method.
Like the yesterday we done.
Yeah, the yesterday method which we learned. The method which we learned yesterday.
72 and 140.
Yeah, exactly. These two numbers. Right after this, we'd be learning about relationship between HCF and LCM also. Okay, no? So meanwhile, finish this question. Yes, Habib.
So
By the way, do one thing now, Habib. You shared the syllabus of your PT1 and PT2 also. Okay, na? Accordingly, we'll be doing the chapters because in your final exams, basically those chapters will be coming in your final exam. So share the syllabus of PT1 and PT2 also.
okay.
Mhm. Also, if it would be possible to send it in the class, during the class, send it during the class if it will be possible on my WhatsApp number. Which multiple of 72 have you taken initially? 72 ones are or 72 twos are?
Ones.
Okay.
Sir, I got
Yeah, what answer you're getting?
4.
Mm-hmm. 4. Yeah,
4,
that
yes.
is very good. So 72 ones are 72. Thereby you have 68. 68, then 72 becomes the new dividend. 68 ones are 68. Thereby you have 4. Subtracted 68 from 72, you have 4. And then you have 68. 4 17s are 68. And the remainder is 0. Thereby this last divisor becomes the HCF. Very good. So you have understood this. Very good. Okay. Do let me know once you share the syllabus. Okay. So furthermore, we are going to learn about the properties of HCF. We have discussed HCF and we have learned the various methods of finding HCF and we did practice some questions. Right now, let's learn about the properties of HCF. We already
Sir,
know that. Yes.
my mom told that I will send syllabus after class.
Okay. 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 No worries. So we already know that HCF of any two number, like we have a number A and B. Right now, like A and B, why I'm not saying any taking any original number, because for example it could be any number A and B, right? In place of A it could be any number, in place of B it could be any number. So for any two or more than two given numbers, the highest common factor, the highest common factor of the given number is basically HCF. Right now we did learn about this. Furthermore, talking about some of the properties of HCF, they are as follows. Read the first property, read this one. The HCF of two or more
Uh,
numbers
the
divides each of the
HCF,
numbers. Hmm.
the HCF of two numbers divides each of the numbers without a remainder. The HCF of two more numbers is a factor of each of the numbers.
Hmm.
The HCF of two or more numbers
Hold
is
on there, hold
always
on there, hold on there. First of all, let us talk about the first two properties. So it's a general thing that HCF of any two or more than two numbers would be dividing each of the given number by without leaving any remainder. That's a general thing. In fact, any factor of a number would divide it without leaving a remainder. Like for example, 18. 2 is a factor of 18. Of course, it is a factor. And when you divide 18 by 2, you'll be getting the remainder as 0. Right now, quotient is 9 and remainder is 0. Right? Or you take any number like 42, you divide this with 3. So thereby, it would be giving you quotient as 14 and the remainder would be 0. So these are the factors, right? But talking about the
yes.
highest common factor of these two numbers, for example, 18 and 42. So talking about the highest common factor of these two numbers, we can find it out like for first method where you'd be listing out the factors. The factors would be 1, 2, 3, then it would be 6, 9, and 18. For 42, it is going to be 1, 2, 3, and then 6, 7, 21, and the number 42 itself. So hereby,
Yes.
which is the highest common factor between the two? It's obvious that it is. Notice.
Highest common factor 6.
Of course, 6, no?
Yeah.
And 6 will also be dividing it just like a normal factor. 2 will be dividing 18 and giving remainder 0. 3 would be dividing 42 and giving the remainder as 0. So this highest common factor will also divide them and give the remainder as 0. It's a general thing. Nothing too special about it. Okay. Talking about the second property, as if of two or more number is a factor of each of the numbers. Is a factor of each of the numbers. See the number, for example, we have numbers 18 and 42. The highest common factor 6 is the factor of both the numbers, right? Then the third property says that HCF or two or more numbers is always less than or equal to each of the numbers. So here the number 6, which is a HCF, it is always less than the given number. That's the general property. But then talking about HCF for two or more prime number, it will always be 1. We know about prime numbers. Give some examples of prime numbers.
Prime numbers.
Yeah.
Like 2, 3, 4, 5, 6, 7.
Not 4,
No.
not 4 is
2, 3, 5, and 7, 10.
hmm,
No,
not
9,
10.
9.
not 9.
9, 11, 13.
9 is not a prime number. It is a composite number. It has more than two factors. Okay, like for example 11. So when you write down their factors are as follows: 1, 2, 1, 3, 1, 5, 1, and 7, and then 1 and 11. The only common factor, or we can say the highest common factor of these prime numbers is only, yes,
What?
the common factor of these prime numbers. Observe it. So what is the common factor of these prime numbers listed over here?
1.
Of course, it is 1. No? So
Yeah.
in every case, whenever you have two or more than two prime numbers, the HCF will be 1. So that is one property, another property of HCF which we have learned. Next thing, we are going to learn about the relation between HCF and LCM, how these two share some relation. Okay, na? How these two are going to share some relation. By the way, in your book also, you have got some questions based on this property. So thereby we'll be learning about this property. Okay, now see. So basically, say we have any two given numbers, right? Say for example, we have a number like m, or let us say we have an unknown number. Let us say it to be a and b. So you have any two unknown numbers, let's say a and b. So the product of these two unknown numbers will be equal to the product of the HCF and LCM. HCF multiplied with LCM. Getting it, Habib? Like for example, let's take one example. Let's take two examples. For example, uh, say we have a number 15 and 18. Okay. First of all, we will find their HCF and their LCM. So let us find their HCF and let us find their LCM also. And then we will find out if their product will be equal to the product of the actual numbers. You getting it? What we are trying to do here?
Yes.
Good. So for 15 and 18, the factors are, quickly mention the factors of these two numbers.
10. Like 1,
Hmm.
1, 3,
Yes.
5,
5,
and 15.
15. Good. For 18, it is
1, 2,
Hmm.
9,
You missed 3,
3, 3, 6,
6,
9,
9,
18.
and the number itself 18. So which is the highest common factor? Is it 3? Is it any other number? Is it 5,
3,
6?
3.
It's of course 6, no? Okay, so just simply write down the HCF that we have found out to be 3. Now it's time to find its LCM. Okay. So 15 and 18. We need to find their lowest common multiple, right? So we can write down the table of
Lowest
15.
common multiple is 1.
Lowest common multiple is 1. 1.
1,
See,
yeah.
how can 1 be a multiple of these two numbers? 1 is always a factor now. In this case, 1 can never be a multiple of any number apart from 1. 1 is the multiple of itself, but 1 is the factor of every number. This is the question which we did in the beginning while you were writing the definition. Remember that 1 is the factor of all numbers. That is the first point. Second point is that 1 is the multiple of itself only. Keep these 2 points in mind. Okay, got this, no? So let us find out the LCM. So we have learned about LCM. You can find it out using the various methods. First of all, let's use the first method where you'd be required to find it out using the listing method. Let's do it using the listing method, or you can do it using the prime factorization method
Yeah,
also.
5 factors.
So do the prime factorization method and find out its LCM quickly. We have numbers
15
15
and 18.
and 18. Okay.
So I got
That is.
um,
Mhm.
15. I got 3 and 5 and 18, 9 and 2.
Okay, but you have to break it in the form of prime numbers. No? 9 is not a prime number. 3 times 5, that is okay. 2 times 9, okay. Furthermore, break 9 into 3 times 3, okay. Got this now?
Okay.
Okay. So here you have 3, 5, 2, 3, and this 3. You know how we have to find out the LCM using prime factorization method, right? Getting it now? So what we used to do there,
If,
remember?
yeah, remember.
So
If
find out the
there's
LCM.
two threes in 18, we should write 1 3
Hmm,
and then done.
exactly.
3
So you would
into
be
5 into
hmm,
2 into 3.
very good. Right now, this 3, this 2, this 5, and this 3. That should be giving you, yes, Habib, that should be giving you how much?
Um, Wait, I'm doing.
Quickly multiplied.
405.
How can it be 405? 3 fives multiplied 2s and 3. 3 fives are 15, 15 twos are 30, 13 threes are 90. LCM would be 90 now. See where you have done the mistake? You're on mute.
I did by mistakenly 15 into 3.
No, that you don't have to do. Okay, no? You have to only multiply the prime numbers, not the given number itself. Okay. So 3
Okay.
times 90. Okay. So 3 times 90 would be giving us 270. What about 15 times 18? Quickly multiply the number 18 and 15. So let's do it together. 5 eights are 40. 0 in hand we carry 4. 5 ones are 5. 5 plus 4 will be 9. Okay, Habib,
Yeah.
pay attention to the screen. So 1 eights are 8. 1 ones are 1. So 0. 9 plus 8 is? Yes, 9 plus 8 is how much quickly?
9 plus 8.
Hmm,
17.
17. Good. And then 1 carried on to the next column, and 1 plus 1 would be 2. So here you are getting the number 270. So you tell me, what do you infer from this? What do we conclude from this? That the product of two numbers will be equal to the product of its
So what did
HCF
you
and
get
LCM.
answer?
The answer you'd be getting 15 times 18 would be 270 now.
No, I got 370.
How can you be getting 370? Add this once again. See, 5 times 18, here you have got 90. 1 times 18, here we have written 18. After adding this, you'd be getting 270, not 370. Check your multiplication. Show it on your camera. Show it on the camera. I would like to have a look at it. Where you're doing the mistake.
Yeah, I got 200.
Hmm. So here the relationship between LCF and HCF is that the product of HCF and LCM will be equal to the product of the numbers. That is what we have proved here. Hope you understood this.
Yes.
So write one statement. First of all, give the title of the topic. Relation between LCM and HCF. Give this topic. Then write the product of HCF and LCM is equal to the product of to the product of given numbers. So that is the property. Write this quickly. After this, we'll be practicing some questions. Then we'll be moving to next topic.
So we have to write the heading relation between LCM and HCF.
Write the heading first of all, and then write the definition. Write this down as quickly as possible.
So done.
Done? Very good. Another important thing is that, by the way, did you write down this relation? E multiplied B equals to HCF multiplied LCM. Okay, write down this too. Write down this too. Write down this and put that in under bracket. Good. Now next thing is that, like, as we have written the
So under
product of,
bracket means
like, close them in this box. I mean to say, actually, in a
okay,
box.
done.
Okay, and do that also. Okay. Furthermore, as we have written over here, like, A multiplied B equals to HCF into LCM. As you wrote down here, that A multiplied B, A and B here are the numbers basically. Okay, now two unknown numbers which we don't know. Could be any number. LCM times HCF. Okay. So furthermore, can't I write down this like this also? Say for example, can I write it like this? A. Say for example, if I don't know what is the LCM of the given number, if I don't know the LCM of a given number, what the LCM is. If listen very carefully to what I'm saying. If, say, the number A and B are given, and you are provided with HCF also, but you don't know what is the LCM of the given number. So how can you do that? You can do that by simply A multiplied B. Here, on the other side of the equal to sign, here HCF is in multiplication. Bring it to another side of the equal to sign, and this here it will be in division. It would be upon HCF. So thereby LCM will be equals to A multiplied B upon HCF. So whenever you are required to find LCM, if you are provided with the given numbers and you know the HCF, but in the question LCM is not written, so directly using this formula you can find it out. It's the same formula, but we have done some changes. We have changed the position of HCF from here to here. Here it was in multiplication. As per the rule of mathematics, whenever you change the position of given numbers from one side of the equal to sign to the another side, in order to do that, you have to change its operation. Here it was in multiplication, here it came under division. You understood this?
Yes.
Good. Another thing is that suppose that you are provided with the number A and B, and you are provided with the LCM also, but you don't know the HCF, what the HCF of that number is going to be. In the previous step, you were not aware of the LCM. So here what you can do, basically you will be writing it A multiplied B. Now here LCM will come under division. You will bring LCM to the other side of the equal to sign. It would be upon LCM. So HCF can also be found out using this formula. Are you understanding this? What we are doing here? And
Yes.
when we will be doing, when we would be doing this, like out of the 4 values, if only 3 values are given, then we can do this. You can use this formula. Okay. So right now we would be doing some questions based on this, and then you would be able to understand this further.
So
Okay.
we have to do by this formula, this A multiplied by B.
Yeah. Okay. Now we would be using this formula. Either we could be using different formulas also, but it is rather simple, not very technical or very complicated. Okay, no, not that difficult. Okay. So let us do some questions on this. The question is that if the LCM and HCF of two numbers are 126 and 6 respectively. And further question says that if one of the number is 18, find the other number. Okay. So that is the question, but let us get back to this slide. In the first two cases, I did told you that if LCM is not given, this formula can be used. If HCF is not given, this formula can be used. Okay, na? Based on the requirement of the question, you can twist this formula. Okay, the fundamental structure of the formula remains same, but just you have changed the switch the sides of the values from one place to another. So say for in another situation, you're facing another situation where let's say you don't know what A is, but the number B is provided, but A is not provided in the question. Listen very carefully. First number A is not provided, but the second number B is provided. In the question, HCF is also given and LCM is also given. So in that case, what you can do, that will be A equals to HCF multiplied LCM upon B. Right now. So you notice this here, that whatever value is not given, you have to find it out. So you will keep it on its own place. Okay, now, and put the other values on the other side. Here it was in multiplication. Upon changing, here it came under division, because opposite of multiplication is Habib. You there in the class? Opposite of
Yes.
multiplication is division, na? Okay.
Yeah.
So try understanding this question. The question is A multiplied B equals to LCM multiplied HCF. Okay. So one of the number is given, that is 18. So write the number. Let's
18.
say that A is given as 18, but you don't know B. You can take any number as 18. You can either take A as 18 or either take B as 18. Okay, now it's not very, you have to strictly follow that. What is the LCM given in the question?
LCM in the given question.
If the
Hello?
LCM, yeah, if the LCM and HCF of two numbers are 126 and 6 respectively, LCM is
126. LCM
and
126.
HCF is
6.
6. Okay. No, you don't know the value of B. That's what you have to found right now. Okay. So what you can do, you will keep the B at its original place. Pay attention here, Habib. Pay attention in the class. Okay. Then you will bring 18 from this side to another side. That is upon 18. Okay. Here it comes in division. 126 times 6. Multiply this quickly. Multiply 126 with 6. Yes, do the multiplication fast.
750.
Just 750 or 756?
Just 750. No,
6, 6 or
756 sounds.
756, no, 756 divided by 18. Okay. Then divide this. So thereby 18 fours are 72, right? And 18 twos are 36. So 18 times 42 gives you 756. Okay, do the division yourself.
So I got 42%.
Very good. So that is 42. Okay, na? So the other number is 42. The other number is 42. So thereby the B is 42. Okay. Have you understood what is actually happening in the question, what we are doing in the class?
Yes.
Hmm? Okay, if I were to ask you to verify your answer, you can verify your answer also. How are you going to verify the answer? So as per the rule, we know that the product of the two numbers will be always equal to the product of LCM and HCF. So LCM is 126, HCF is 6. The first number is 18, another number you have found it to be 48. So when you will be multiplying 18 with 42, you should be getting the equal to the product of 126 and 6. That is 756 you should be getting. Okay, Habib. So let's verify it also. A times B equals to LCM multiplied HCF. 126 times 6, and here A was 18 and just now you have found B to be 42. Now how can we can have to simply verify it, no? So quickly multiply 42 with 18, and 126 times 6 already you know that is 756, as you have found out moments ago.
18 multiplied by 42.
Exactly.
Seven fifty
750, 756.
6.
So aren't the two values on the left side and right side equal? It is
Yes.
obviously equal. So By verification, we found out that yeah, we have verified our answer. It is actually true. Okay, na? Usually it will not be asked to do, but in your rough paper, you can do it in examination to check whether your answer is correct or not. So you have understood the mole concept, the fundamental concept of how this formula would be used. Okay, now any confusions in this? Please let me know. Yes, Abhi. If there's any confusion in
I
this,
don't know.
please let me know. Okay. We'll be learning about divisibility rule, but I think you should be solving one or two more questions at least. Okay, na? Um, so let us do one more question, and then you'd be, if time permits, we'd be beginning with the next topic. So say that the LCM and HCF of two numbers. It's a question. LCM and HCF of two numbers are 350 respectively. Okay, ये LCM and HCF हमें provided है. And if one of the number is 150, you have to find the other number. If one of the number is 150, find another number. You have to do this. The first one I solve it. We did together solve it. The second one you solve it quickly. You know the formula? The formula
Yes.
would be
The first number is, what did you tell?
the first number. If one of the number is 150, so you can either take A as 150 or B as 150. Okay, no? Take any number as 150. By the way, this one is very simple. From the previous question you did, this one is comparatively simpler.
Sir, I got the other number 600.
600. Okay, I don't think the answer you're getting is correct, Habib. The reason is why. See, simply when you put the given values, LCM कितना given है हमारे पास? What is the value? LCM is 300,
6.
no?
Yeah.
300. And HCF is 50. One of the number is 150. So let's take it to be 150. B we don't know. When you obtain the product of 350, it would be how much? 50,000, no? 15,000, I mean to say. Right? That is 15,000, isn't it? Okay. So if you are saying me that the other value you have got is 600, right? That's what you are saying. So that would be how much? 150 times 6 is 900 and then put these two zeros also. So are these values equal? Of course it is not equal. So thereby, logically speaking, without even having the need to calculate, although you have to do the calculation, but logically speaking, should I not be multiplying it with 100 to get the value 15,000? Yeah.
Yes.
So your answer should be 100, not that. Okay. So see
Okay.
where you have done the mistake. Point out your mistake. Yes. Look at
First,
this your solution. Hmm.
I have done like 50 divided by 1.
No. The order of operation you have done was incorrect, I think. Okay. So 15,000 would be divided with 150. This 150 on going from here to here, I should be multiplying it with this now, of course. Here I have written directly 15,000, like by multiplying it, I have written. Okay. So that would be upon 150 and thereby it would be 100. So B is 100. So hope that was clear and you understood this, right?
Yes.
Okay. Okay. Before ending the class, let us do some more questions on this. Okay, now. Or how about have you understood this topic completely? I think you should be practicing one or two more questions. Then it would be 100% clear. Okay.
Okay.
So now I'm changing the question a little bit. In this, I'd be asking you to find the LCM. Okay. So question is that I'm directly writing the given values only. Okay, now. So the LCM of 24 and 45 is given as 360. What will be the HCF? What will be the HCF? The formula is A times B equals to HCF multiplied LCM. And what do you have to found? You have to found the HCF. So remember the formula of HCF. What you have to do? HCF equals to A multiplied B upon LCM. Okay, Habib. Do one thing on the corner of your page. Write down this formula. That will help you solve the question. Write it down this formula, and while solving, take this as a reference.
So done.
Done. Okay, now solve it quickly. Solve the question. Alif, do you have a class at this time?
Yes.
No, I'm actually asking to Alif. Yeah, Alif, do you have a mathematics class or do you have a test at this time?
Sir, mathematics class.
Okay. It would be beginning in just a few minutes, in few seconds.
Okay,
Yeah,
sir.
Habib, quickly answer the given question. What value you have got?
So I'm doing.
Okay, do it as part of